Okay guys, welcome back. So I'm actually going to make two more videos. So one going over this example, and then I'm going to pick one of these challenge graphing questions, probably this one. I want to do a cotangent one, and I'll make a video for that as well. Alright, but realize with these are challenging, okay? So don't think that, especially with everything going on right now, that we're going to expect that you know how to do these easily. These are all pretty tricky, okay? This one especially, you got the double star here. If you really are bored and you want to give yourself a good challenge, this is a good one to try and make. And that'll be it. Okay, so going back to this graph, I still like to list out the four characteristics, okay? So I'm going to write, even though it doesn't really apply a lot of the time, the amplitude is 3 from here. And I'll show you actually what we can do with this if you really want to get a good, accurate sketch. So the next thing we need to write down, or I like to write down, is the period. That's going to be pi over a half, which is actually 2 pi, okay? So because x is divided by 2, that actually stretches the graph horizontally, so our period becomes 2 pi, which is larger than the normal period of pi. I'm running out of room here. The center line is 0, and the phase shift is 0, because we don't have any numbers added or subtracted to x, which might affect the center line. Numbers added or subtracted to x would affect the phase shift. We don't have any of those. We have no numbers added or subtracted on the outside, so we don't have a center line change. All right. So let's use black to make these first, the starting point. So the center line is 0, and the phase shift is 0. So I am going to draw these out. It's not too good. Let's redo that. Can do better than that. Let's draw these axes out. That's going to be good enough. Okay, so this is x equals 0, and this is y equals 0. Let me make this a little bit bigger. We know the period is 2 pi, so we're going to use that to kind of build the graph. We also know the amplitude is 3. Tangent. Again, tangent is sine over cosine. So this is really like sine x over 2 over cosine x over 2 times 3. So if I look at the top, when sine is 0, this graph is going to be 0. Okay, so sine is 0 at, let's get another color here. Let's go with blue. At 0. And I'm just going to make pi over 4, pi over 2, pi, 3 pi over 2, 2 pi. So pi over 4, pi over 2. Sorry, let me change this up. This is pi over 2, this is pi. And this is going to be 2 pi. So every 2 units will be pi over 2. Maybe that's too much to show. Let's get rid of those. Since the period of this thing is 2 pi, right? The next time I have a 0 is going to be right here. Okay? And halfway between these zeros, if we've done it right, we should have a vertical asymptote. So this is x equals pi. Let's just double check that. If I put pi in here, right, the sine of pi over 2 is 1. But the cosine of pi over 2 is 0. So asymptote is correct. Let's go the other direction. So 1, 2, you guys can laugh at me trying to count these out. 4, 6, and then 8. Okay, so that's a pi, by the way. This is negative pi. This is negative 2 pi. 0 at 0, 0 at 2 pi, another 0 at negative 2 pi, and another asymptote at negative pi. All right, if we want to double check that, you plug it in and get the mouse. Take this, plug it in here, the cosine of negative pi over 2, well, that's like, down at the bottom of the unit circle, the cosine of negative pi over 2 is 0. So yes, it should be a vertical asymptote. We know the direction is going to be up because the direction is going to be increasing because tangent is always increasing, and there's no negative here that would be some sort of reflection. But here's where this amplitude can come in, right? So in between 0 and pi is pi over 2, right? So this is actually pi over 2. Now, if I take that value and I normally plug it in, right here, the tangent of pi over 2 is the tangent of pi over 4, which is 1. Okay, so a normal point, the normal point would be here. But because we have this 3, that actually increases the steepness of the graph. So 1, 2, 3. So I'm going to mark this point here. Okay, and that point, let's get a different color. So this, let's do orange. This point right here is pi over 2, comma 3. Now these tangent graphs are symmetric, right, about the origin. So that means if I'm going pi over 2 over and 3 up, pi over 2 to the right, 3 up, I can go pi over 2 to the left and 3 down. So if I count out, I think it's 6, right? Yeah. 2, 4, 6. That point is negative pi over 2, comma, negative 3. Okay? Let me erase some of this stuff. So this is out. Let's get rid of that. Let's get rid of those. Bothers me that the axes are broken now, so I'm going to fill that in. This also bothers me. I don't want to make this orange. I want to make it blue. 2, 4, 6. All right, so our graph is going to look something like that. Okay, but it's a little bit more vertically stretched. That doesn't look so good. I'm trying to get this better. Let's make that point of inflection show there. So something like this. Okay, and it's going to approach these asymptotes. If we want to do another cycle, right, then we could go 2 pi units from pi over to 3 pi. So that would be 1, 2, 3, 4, 1, 2, 3, 4, right here. So this is x equals 3 pi. And then I can kind of just transfer the points. So this is going to be right there. This point here is going to be 2 over 1, 2, 3, 4, 5, 6. All right, and we get another cycle of tan graph. Okay? So, yeah, they're different, but not too bad once you practice and get the hang of it.